So we have defined what is population, what is sample, and what are the ways of drawing a sample from the population. Now let us see the problem on simple random sampling, which is the first sampling technique of random sampling here. So a population consists of elements 2, 3, 4, 5. Consider all possible samples of size 2 that can be drawn with replacement. Right? Then find the first bit, mean of the population, standard deviation of the population, mean of the sampling distribution of means, and standard deviation of the sampling distribution of means we have to find. So to find that, definitely we have to use the calculator here. Right? So we know that we can draw a sample from the population with replacement in capital N power small n ways. Right? So if you consider the solution here, population size is here 2, 3, 4, 5. Means the number of elements in the population are 4 and the sample size is clearly given as 2 here. So they are asking with replacement. WR means with replacement. So we can draw the samples with replacement from the population in capital N power small n, that is 4 square equal to 16 samples. Right? Now the first bit is here, we have to find the mean of the population. So mean is known as the parameter of the population, which is denoted by mu here. So mu equal to, the formula is 1 by n summation of x. That means here x equal to some 2, 3, 4, 5. So 2 plus 3 plus 4 plus 5 by how many elements we have? 4. Give the values in the calci under regression linear mode here. Right? So for this here, you have to press the mode key for 2 times. Then you will get regression. So here the option for regression is here 2. Press 2. Again it is asking linear, logarithm, exponential. Go to the first option here, linear. Right? Now the population elements are 2, 3, 4, 5. So give the value 2. Right? Press n plus, that means the first observation. N equal to 1 means the first observation is stored in the calci. Then again give the value 3, n plus, second observation is stored. Then 4, n plus, third observation is stored. Then the last one, 5, n plus, the fourth observation is stored. Now if you press here, shift 1, right? Here we have summation x square, summation x and n, where n represents the number of elements given in the calci. Then summation x means here sum of all the observations, right? So for that the option is here 2, press 2 equal to, so it is here 14. So 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 5 is here 14 by 4, right? Now if you press here shift 2, then it is here we have x bar, sigma x and capital Sx. So here mean is denoted by actually mu, mean of the population is mu here. But in the calci it will take the values of sample only, right? So press the option 1 equal to, so it is 3.5 here. Okay, so the mean of the population is here 3.5. Then the second bit is here, we have to find the standard deviation of the population. So standard deviation is denoted by here sigma. So it is given by the formula here, root over summation x square by n minus mu square. Okay, so that means root over, now again press shift 1. So summation x square for that option is 1 here. So 1 equal to, it is 54, right? So 54 by the number of elements are here 4 minus mu square means 3.5 whole square, right? Now again press shift 2. So here sigma x is the standard deviation symbol is there in the calci directly. So press 2 and equal to, it is here 1.11. 1.118 here. So 1.118. So this is the standard deviation of the population. Now the third bit we have to find is here mean of the sampling distribution of means. So first of all we have to consider the sampling distribution with replacement. So sampling distribution with replacement. So here we have to consider a sample of 2 elements from the population here. So with replacement means repeatedly we can take the sample here. So let us consider it as here 2, 3, 4, 5 are the elements. So 2, 2, 2, 3, 2, 4, 2, 5. Means consider all samples possible with the first element 2 here. Right? Since it is with replacement, so we can consider the same element, right? So sample size is 2 only. So how many elements we have? 2, right? Then starting with 3, so 3 2, 3 3, 3 4 and 3 5. Similarly, starting with 4, right? So 4 2, 4 3, 4 4 and 4 5. And starting with 5, 5 2, 5 3, 5 4 and 5 5 here. So with replacement means here 2 2, 3 3, 4 4, 5 5, right? And also here we have 2 3, 3 3 is also with replacement only. Okay. Now we have to find the mean of the sampling distribution of means, right? So we have to find the first sample means. Right? So sample means here mean formula is sum of all observations by number of observations. So 2 plus 2 is 4. How many elements we have? 2. So 4 by 2 is 2. 2 plus 3 is 5. 5 by 2 is 2.5. 2 plus 4 is 6. 6 by 2, 3. 2 plus 5 is 7. 7 by 2, 3.5. Okay? Then 3 plus 2, 5. 5 by 2 is 2.5. 3 plus 3, 6. 6 by 2, 3. 3 plus 4, 7. 7 by 2, 3.5. 3 plus 5, 8. 8 by 2, 4. Then 4 plus 2, 6. 6 by 2, 3. 4 plus 3, 7. 7 by 2, 3.5. 4 plus 4, 8. 8 by 2, 4. 4 plus 5, 9. 9 by 2, 4.5. Then 5 plus 2, 7. 7 by 2, 3.5. 5 plus 3, 8. 8 by 2, 4. 5 plus 4, 9. 9 by 2, 4.5. 5 plus 5, 10. 10 by 2, 5. Right? Now these are means of the sample. We have to find the mean of the sampling distribution of means. Means we have to find the mean of all these means here. Now again, let us store the values in the calci here. Right? Because it will take some time to make a sum of all these and making a square of that. Right? So let us, first of all, we have given the population data in the calci. So we have to erase the data here. So to erase the data, we have to use here shift mode. Then you will get 3 options here, SCL, mode and all. Right? If you press here all, the option 3, then whatever the data you have given in the calci, that will be erased. Right? Then press equal to. Right? Now again go to the regression mode and linear. Okay? Now give the only means 2, 2.5, 3, 3.5. So 2m plus 2.5m plus 3m plus 3.5m plus 2.5m plus. So here 2.5 is there and here also 2.5 is there. But still you have to give the 2.5 2 times because here the calci will record the number of observations we stored. So how many observations we have? 16. Right? So we should have 16 samples in the calci here, even though the number is repeated twice or thrice. Okay? So 2.5, then after that 3m plus 3.5m plus 4m plus 3m plus 3.5m plus 4m plus 4.5m plus then 3.5m plus 4m plus 4.5m plus and finally last element 5m plus. So n equal to 16. That means all the 16 means are stored in the calci. Now press shift 1. Right? Here it is summation x. Right? But here we are finding mu x bar, mean of the sampling distribution of means. So mu x bar equal to summation x bar by how many observations here we have? That is 16. Right? So it is here given by 56. So 56 by 16. Okay? Then again press shift 2 and the first option it is 3.5 here. Okay? Then the last bit you have to find is here standard deviation of the sampling distribution of means. That means the notation is here sigma x bar. Right? This is sigma x bar. It is given by the formula summation x bar square by 16 minus here mu x bar square whole square. Okay, so that means here summation x bar square means in the calc it is summation x square. So it is 206. So square root of 206 by 16 minus 3.5 square. So now again let's shift to, again we have sigma x to equal to, so 0.79. Okay, it is 0.7906. So remember here, always the mean of the population and the mean of the sampling distribution of means must be equal. Okay, that is 3.5 and 3.5. But whereas here, the standard deviation of the sampling distribution of means should be less than the standard deviation of the population. Because whenever the sample size increases, definitely here the deviation also should reduce. So there we have 0.7906 and here we have 1.1118. So that is the condition it should be satisfied. So in this way we have to consider the with replacement samples and we have to find the mean and deviation of the sample. So see one more problem on with replacement. Find the population mean, population standard deviation, S3 means standard deviation, mean of the sampling distribution of means, standard deviation of the sampling distribution of means, where the population consists of 1, 5, 6, 8. So draw all possible samples of size 2 with replacement here, right? Now here also the population size is 4. So those are here 1, 5, 6, 8 and the sample size is 2 here. Okay? Now if you see the first bit here, mean of the population is denoted by mu and given by the formula summation x by capital N here. So summation x means here x is 1, 5, 6, 8, sum of all, right? Now again go to the calc, press the mode, regression mode, linear. Now give the values 1m plus, 5m plus, 6m plus and 8m plus. So 4 observations are stored. Now let's shift 1, summation x option is 2 equal. So it is 20 by 4. Of course it is 5. So to find that also we can use here shift to second option, right? Then here second bit we have to find is here sigma, standard deviation of the population, right? So here square root of summation x square by n minus mu square. So again press shift 1, the first option summation x square. So it is here 126. So square root of 126 by 4 minus mean is here 5 square. Now press shift 2, right? Second option is standard deviation equal to, so it is here 2. Fix your calc after decimal for 4 digits. So 2.5495. Okay, that is the standard deviation of the population here, right? Now, next we have to find the mean of the sampling distribution of means. But before finding that here, we have to consider the sampling distribution with replacement, right? So, with replacement, the formula is here capital N power small n, that is 4 square equal to 16 samples you will get here, right? So, what are those 16 samples? So, it is given as here, the element is 1, 5, 6, 8. So, 1, 1, 1, 5, 1, 6, 1, 8. Then similarly starting with the second element. So 5, 1, 5, 6, 5, 6, 5, 8. Then third element is 6 here. So 6, 1, 6, 5, 6, 6, 6, 8. And the last element is 8. So samples with 8 is here 8, 1, 8, 5, 8, 6 and 8, 8. So totally there should be 16 samples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 samples are there. Now we have to find the means of these samples, right? So mean of samples. So sum of all observations by number of observations. 1 plus 1 is 2. 2 by how many elements are there? 2 elements are there. So 2 by 2 is here 1. So 1. Next 1 plus 5, 6. 6 by 2, 3. Then next 1 plus 6, 7. 7 by 2 is here 3.5. 1 plus 8 is 9. 9 by 2 is 4.5. Then here next one is 5, 1. 5 plus 1. 5 plus 1 is here 6. 6 by 2, 3. Then 5 plus 5, 10. 10 by 2, 5. Then 5 plus 6, 11. 11 by 2, 5.5. Then 5 plus 8, 13. 13 by 2 is here 6.5. Okay. Then here, so till we have completed 4, 5, 6, 5, 8, right? Then 6 plus 1, 7. 7 by 2 is 3.5. Then 6 plus 5, 11. 11 by 2, 5.5. Then 6 plus 6, 12. 12 by 2, 6. 6 plus 8, 14. 14 by 2, 7. Then 8 plus 1, 9. 9 by 2, 4.5. Then 8 plus 5, 13. 13 by 2, 6.5. Then 8 plus 6, 14. 14 by 2, 7. And 8 plus 8, 16. 16 by 2 is 8 here. So we have to get here 16 beats. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now we have to find the third bit here. What is that we have to find? Mean of the sampling distribution of means. So it is summation x bar by 16 here. Now again, just delete the data, whatever you have given for the population. Then you just go with the means data here, right? So go to regression, linear. So 1m plus 3m plus 3.5m plus 4.5m plus then 3m plus again 5m plus 5.5m plus 6.5m plus 3.5 then 5.5 6 7 4.5 6.5 7 and 8. So 16 means are stored in the CALC. Now shift 1 summation x option 2 it is 80. So 80 by 16 is how much here? Again press shift 2 first option it is 5. Then fourth one we have to find is sigma x bar, that is standard deviation of the sampling distribution of means. So it is here square root of summation x bar square by 16 minus mu x bar square. Okay, so square root of here shift 1 first option that is summation x bar square 452 by 16 minus here it is 5 square. Okay, so press shift 2 and second option it is 1.8028. So here mean of the population is 5, then mean of the sampling distribution of means is also 5, both should be equal. Then standard deviation of the population is 2.54 and standard deviation of the sampling distribution of means is 1.8028 here.